Okay, peeps. The answer to this guy, pay close attention, is x comma y, 2, x plus 6, y plus 4. Okay, I do know some of you put it like this. This is still the same transformation, but why is this the only answer and not this guy? Ronnie?
It says write a rule.
Very good. Okay. If it ever says write a rule, it needs to be in rule format. This is the transformation as a rule. What do we call this? Does anyone remember the name of it?
It starts with a C.
Yeah, it does start with a C. Yep.
Component.
It's component form. Okay. It's the component form of the...
The translation.
Yeah, but more specifically, it starts with a V. Vector. Okay. This is a vector. Okay. This one is the rule form. Okay. We Gucci? All right. Were there any questions from last night's homework? Adding another transformation, that transformation is called a reflection. Okay. What do we think about when we hear the word reflection? John?
Like the same.
Okay. The same. A mirror. I love that. Okay. So let's write that down. Same. Mirror. What else?
Symmetrical.
Symmetrical. Wow. That's literally the best one. Symmetrical. What else? A reflection. Yeah, that's the word that I was asking for us to make associations with. So when you hear the word reflection, you think of reflection. That's perfect, Hayden. Okay, what else do we think about when we hear a reflection? Can we think of one more? Opposite. I like it. Okay. Now, it's weird because John said the same and Hayden said opposite. And a reflection is kind of like both of them, okay? So it's the same figure, but it is flipped over a mirror, okay? So what today's lesson is we're going to have a mirror on our page and we're going to reflect an image over that mirror, okay? So by definition, a reflection is a transformation that uses a line like a mirror to reflect a figure. The mirror line is called the line of reflection. Okay? I want you guys to also highlight the word mirror because that's super important. And then take a look at the picture. That's the mirror of the hand. I want you guys looking at the mirror of the hand picture, okay? Now, notice the knuckles, right, of the guy's hand that aren't touching the mirror. Do you see how there's space between his hand and the mirror image of the knuckles? There's space between them. What doesn't have space between it?
The connecting.
The finger, the tip of his finger. Do you guys see that? Just highlight the tip of the finger for me, okay? Because that's a super important concept that we understand is that if there's a point and it lies on the mirror, okay, when you reflect it, what do you think happens to that point?
It's the opposite.
It would be the opposite, but if it's on the mirror and you reflect it,
They would be touching.
it wouldn't change.
At a single point.
It would be touching, so it wouldn't change, okay? So that's a super important concept, okay? Now, so what I want you guys to distinguish is and don't write anything down just yet, okay? Just look up here. This point P, right? The reflection P prime is at the exact same point. If it was reflected over our mirror, the line M. Why? Because P lied on the mirror. Do you guys see that? Now, if our point P lied off of the mirror, like over here, where does it get reflected to? The other side of the mirror, okay? Now, one thing that you should notice, what angle gets created by the line of reflection over the line, over the line of reflection? A right angle, okay? It must be perpendicular here. Okay, now you can start writing, okay? So if there's a point P and it's not on the line M, M is the perpendicular bisector of P prime. Or if P is on the line M, the mirror, then P is equal to P prime. They're the same point, okay? So if you're off the mirror, you are going to get reflected the same distance that you are away from the mirror. If you're touching the mirror, does your point change? No. Okay? If that point is located on the mirror, the line of reflection, when you reflect, it doesn't change. Okay? All right, let's try one. So, plot the points A, B, and C, 1, 3, 5, 2, and 2, 1, and then we're going to do its image. 1, 3 for A, 5, 2, and 2, 1. What kind of shape is this?
Triangle.
How'd you know it was a triangle?
Because it looks like one and it has 3 sides.
It looks like one. Has 3 points, it has 3 sides. Excellent. Okay. Now, it says we have to reflect it over the line N. Okay? So write this down. This line, x equals 3, is our mirror. Okay? What kind of line is x equals 3? Hayden?
This way.
A horizontal line?
Yes.
Wrong.
Vertical.
It's vertical. Why?
Oh, because it goes through the X.
It goes through x equals 3. Where's x equals 3? Right here, right?
Yeah.
Okay? It's a vertical line that goes through this.
Yeah.
What kind of line would be horizontal? What would our equation look like if it was horizontal?
0, 3.
No, that's a point. What kind of equation would it be if it was a horizontal line? Y equals a number, okay? Whenever it's x equals, write this down. This is a vertical line, okay? Horizontal lines are when y is fixed at a number, right? Because your y value would then be fixed and all your x values are changing. Right now, look at this line, guys. Look at the blue line that I drew. Would you agree at all of these points, my x value is what? 3, right? But my y values is all different values. So if x has to be 3, y can change, but x has to be 3. Do you guys see that? So that's how it creates a vertical line. Does that make more sense?
Yeah.
Now, this line is our line of reflection, also known as our mirror. So label it, okay? It's our mirror. Now, let's start with point A. You want to draw a perpendicular segment from A to the mirror. Do you agree our mirror is vertical? What's perpendicular to a vertical line? Horizontal. So horizontally, draw a segment from A to the line. How long is that segment? 2 units. If we're going to reflect A from the left to the right, how many units away from the mirror should it be on the right side? 2 units. So draw the same segment, 2 units. What's the new coordinates of A? What are the coordinates of A prime? 5, 3. Sophia, you're confused? Which part?
I don't know.
Okay, let's try another one. Let's try B, okay? Take a look at B. Guys, the more practice we do, the more it'll make sense. What's the perpendicular? Like, how can we move perpendicularly to our mirror to get B back to the mirror? Cody? Go to the left 2, okay? So if we move to the left 2 to get back to the mirror, continue moving to the left. What are the new coordinates of B prime?
1.
1, 2. Alexis?
Can we go to the left?
Yes, you may. And lastly, let's do C. Who thinks they get it and can walk me through C? Cody?
It's 1 point away from the mirror, so
It's 1. Yeah, you're right. It's 1 unit away.
so you move 1 to the right on the other side of the mirror, so it'd be 4, 1.
Good. 4, 1. C prime. Now, watch. When we connect all of these, I want you to notice what it looks like. Erase the red that we drew, because that's just getting in the way. Benji said it looks like a mirror. Do you guys see how this looks like a mirror?
Yeah, it's like the opposite.
It's like flipped over that line. Do you guys agree? Now, one thing I want to point out, do you guys remember the word that John said? John said symmetry, right? Do you see how this figure has symmetry on both sides now? Okay? It's the exact same image, just kind of like flipped over that mirror, okay? Questions? Okay, we're going to use the same figure, but now we're going to change our line of reflection. Our line of reflection is going to change to y equals 1, okay? So this is now our mirror. What kind of line is y equals 1?
A horizontal. Wait, horizontal line.
Very good. It's horizontal. I wanted you to wait. All right, so it's horizontal, and it must go through what point, peeps? Y equals 1. Okay, so draw it. This is our mirror. Okay, and then let's label the points. So we've got 1, 3 for A, 5, 2, the same one, B, and then C was at 2, 1. Okay. A prime.
Do you have to move down now?
You do have to move down now. Why are we moving down now?
Because it's a horizontal line.
Good. The mirror is horizontal, right? So what's the perpendicular movement to a horizontal line?
Negative.
Vertical, right? So we're gonna move down 2 to get to the mirror, right? So what are the coordinates of A prime? 1, -1.
Oh.
Okay?
What do you do with C?
So hold on. Wait, we're gonna get there. A, we're going 1 point at a time, guys. A was how many units above the line of reflection? 2. So we move it down 2, and then we move 2 below, and we get to A prime. Do you guys see that? So if it's 2 above, flip it over and move it 2 below. Do you see that?
Where did you get the 2 below from?
What do you mean?
Oh, because it's 2. Oh, okay.
You see it now, Sophia?
Yeah.
Okay. C.
You don't move it.
It doesn't move. Why not? It's on the mirror. So C prime, you're going to put another dot and put C prime here. Yes?
Makes sense.
Now, is B on the line? No, so B is going to move. How many units is B away from the line? 1. And it's above, right? So we're going to reflect it. And what's the new coordinates of B? 5, 0. B prime. Draw your figure. And it's going to look epic. It's a butterfly. Come here. Yes? Any questions?
Mine is a bit wonky.
Why?
I don't know.
If it's lopsided, one of your points is wrong. Okay? It should be completely symmetrical over the line of reflection. Yes, you. How are we feeling?
Great.
Okay. Now, the next one is we're reflecting it over the line y equals x. Okay? Okay, hold on. Let's start. Let's go ahead and graph this
I know
segment,
it.
okay?
I know it.
FG. So F is at -1, 2. Do you guys agree? Let's put F here. Let's put G at 1, 2. Are we cool with plotting that segment? FG.
That's kind of easy.
Okay? That's pretty easy, right?
Yeah.
What is the line y equals x? What do we know about that line, Sophia? It would be at the origin. Do you know why? Very good. The y-intercept, in other words, my b value is what? 0, right? Because there's no constant being added. So it's going to start at the origin. And what's my slope of this line? What's my m value? 1. Okay? So my slope is 1. If my slope is 1, from 0, 0, what's my movement? How much do I rise? How much do I run?
You go one up and then one to the side.
1 up. Which side, though?
To the right.
To the right. 1 up, 1 to the right. 1 up, 1 to the right. So y equals x is this line starting at 0, 0 that has a slope of 1. Do you guys agree? Yeah, hold on, Hayden. This is my mirror. What? Y-int means y-intercept, okay? That was your b value. Your b value is 0. Okay, now before I move on, are there questions on graphing y equals x?
Wait, is that it?
No, we're not done. Okay, now, it's kind of difficult because now that line is no longer vertical or horizontal. Do you guys agree? It's y equals x. When you get a line like this, go to the next example. Our points were f, which was at -1, 2, right? Reflected over y equals x. What are the new coordinates of f prime?
2, -1.
2, -1. The coordinates of g were, that's supposed to be a g, 1, 2. Reflect it. What are the coordinates of g prime? 2, 1. Watch. This is like the coolest thing, okay? So, plot G and F and see what you get.
Oh. The root?
Now, imagine that this is a mirror, right? If you reflect it, doesn't that kind of look like the same thing? Almost like, yeah, almost like a right angle or like an arrowhead, right? When you reflect it, okay? Now, I want to show you one last thing about this, okay? Just so you can make sure that you're right. Do you guys agree that it should be a perpendicular distance and it should be the same distance away from the mirror? So start at G, guys, and use a different color and draw that perpendicular distance down to the mirror. And then draw that perpendicular distance again. Do you see how we got from G to the mirror and then from G to G prime?
Yeah, here.
Okay? And that's perpendicular to your mirror. Do the same thing for F. So draw that line perpendicular and then draw it again. And you should get to F prime. Okay? Interesting, right? Now, this is actually one of the most applicable things to the real world, okay? Architects use this in floor plans all the time. Think about a building, right? Buildings, like, they experience a lot of wind, and sometimes, like, skyscrapers are super tall. They have to use lines of symmetry to make sure that the building is balanced, right? And has the same weight on both sides. Does that make sense?
Wait, what word did you say? For applicable?
Applicable?
Yeah, what does that mean?
That means, like,
Use it.
that you can use it, right? In the real world.
Oh, okay.
Okay? This is super important stuff. Are there any questions on what I did here? Cody,
Why you flip? I don't understand why you're flipping it.
what do you mean? Why am I flipping it?
Like, go to the left of it.
Okay, so this is our rule, right? For y equals x. There's a bunch. Good question. Any other questions on this example? Zach?
I need to just write them.
Okay, go ahead. We have a set of rules, okay? When you're reflecting over the line y equals x, highlight this third one. We're going to use this third one for reflecting over the line y equals x, okay? And it says any point that was AB before is now going to become what?
BA.
Become A, okay? So go back to our rules down on this next one, okay? So the rule when you're reflecting over y equals x is you take the coordinates, which were AB, and you reverse their order and write it BA, okay? Please write this down. Guys, put a star on this one. These need to get memorized,
Oh, no.
okay? if you're reflecting over the x-axis, okay? Reflecting over the x-axis, the image is the point A, comma, negative B. What's the only thing that changed there? They were in the same order, but B became negative. Now let's think about that, right? If you have a point above the x-axis, right? If you have a point up here and you're reflecting it over the x-axis, what's the only thing that you change? The y value becomes the opposite, right? It becomes negative. Now, if you were below the x-axis, right, and you had a y value that was negative, and you reflected over the x-axis, you're just going to make that y value positive, okay? Same thing for if you reflected over the y-axis. So if you reflect it from left to right, your x value is going to change from positive to negative or from negative to positive. So that negative sign here. And then when you reflect over the line y equals negative x, you're not only flipping the order, but you're also changing the sign of both of them. Okay? There's no easy way for this, guys. We have to have these memorized, okay? I am going to quiz you next week, so make sure that these get memorized by next week. Understood? Okay. What day? I don't know yet. Actually, I do know. After that, 3, -1 right here. This is A. B is going to be at 3, +2. So I have a segment, and my segment is vertical. And we're reflecting it over the line y equals -x.
So you have to flip it and then negative.
Good. So now my slope should be negative. I'm still going through the origin, though. Do we agree?
Yeah.
My y-intercept is still 0. But my mirror should look like this for this problem. Now, let's reverse the order here. Let's not know what the coordinates of A prime are. Let's try to figure them out ourselves, okay? So from A, draw a perpendicular line segment down to the mirror. And then try to draw that same segment again. What do you think the point of A prime should be?
-3.
1, -3, okay? Let's talk about why it's 1, -3. So A's original point was 3, -1. Do you guys agree? Reflecting it over the line y equals -x, just jump back a slide and tell me what changes. What has to change if we're reflecting over y equals -x? Give me 1 second, Sophia.
You have the negative multiple and then flip it.
Negative b, negative a. Do you guys agree? That was our rule. We're going to have the rules memorized, but for now we can use that last slide as a cheat sheet, okay? Negative b, negative a. So reverse the order. A prime, reverse the 3 and the -1. So now it's -1, 3, and also change the sign. So it's going to be +1, -3. Isn't that what we got when we reflected it?
Yes.
Cool, right?
Very cool.
Okay. Now B. B's coordinates were 3, 2, right?
So it's going to be -2 and -3.
Good. B prime is going to be -2, -3. -2, -3 is down here. And always make sure we are changing the orientation of our line, right? In translations, our size, our shape, the way it was orientated, it was all the same. We're still not changing the size of our image, okay? This original segment, AB, was how many units? 1, 2, 3. Do you guys agree? Your segment, after you reflect it, should still be 3 units. Do you see how it's still 3 units? Okay? We're not changing the size of it. We're just changing how it's oriented, okay? It was a vertical segment, and we changed it, and now it's a horizontal one when we flip it over y equals -x. Kind of?
No, I got it.
We got it? A little bit? Okay, it may not click right away. What do we do if it doesn't click right away? Practice. Okay, Sophia, what was your question? Yes, you may. What's up?
I'll be honest with you, like, I didn't even do it that way, but I still got it.
Okay, that's fine. But you're gonna have those rules memorized, right?
Yeah.
Thank you. Next thing we're gonna talk about are lines of symmetry, okay? Lines of symmetry are just lines that you can draw through your figure that you can reflect the figure over and maintain symmetry in your figure, okay? So if you draw a line of symmetry, it's gonna be the exact same on one side of the line as it is on the other side, okay? So for example, take a look at the letter A. The vertical line going straight down your figure, this is a line of symmetry because if I took the left side of my figure and I folded it over, do you see how everything would match up? It's the exact same on both sides. There's one other line of symmetry on A, and it's this horizontal line going through the image. Okay? Now, some people tend to think that this diagonal is a line of symmetry.
No, because when you
It's not though.
it's not gonna be the
Why won't, if we folded it over, why wouldn't it be the same? Hayden?
Like, if I had a piece of paper, I could show you.
You could show me if you had a piece of paper? Actually, let's use paper, okay? So do you see how this piece of paper is like a rectangle? If we fold it this way, do you see how it folds completely onto itself?
Yes.
It's like you can't see any part. If we folded it horizontally, do you see how it would fold right onto itself? It has two lines of symmetry now, right? But if I fold it diagonally, look what happens. Did it fold completely onto itself? No. Do you see how there's extra space there? Not a line of symmetry. So how many lines of symmetry does this rectangle have? Just two, okay? No more, no less. Take a look at B. B, there's a lot more lines of symmetry, okay? There's one going down the middle, horizontally, vertically. What else?
Diagonal.
Diagonally, from corner to corner, okay? So from corner to corner, here's one. Here's another one. Are there more?
You could also like that little thing from the right.
From here?
Yes. From right.
Yep.
then
And there's one
right.
more. From the middle of the segment. So how many lines did I draw in total? Well, 1, 2, 3, 4, 5, 6.
Well,
There's actually 6 lines. Because, Hayden, when I go down here, 7 is the same now as 1. Do you see that? Those are the same lines. So how many lines in total? 6 lines of symmetry. LOS stands for lines of symmetry. Okay? How many did the first one have?
2.
Just 2. Erase that diagonal one. That was a counter example. This one had 2 lines of symmetry. Okay. What about C? Be careful here.
It only has one.
Only 1. Okay? It's only that vertical one. Yes,
Do
John.
you put LO or not LOS? Or if it only has one.
LOS. Lines of symmetry. 1 line of symmetry. Why aren't there more here? John?
Because it's like only like fold like with each other.
Yeah, it's like what does it kind of look like?
A shield or
A shield,
an arrowhead.
Duck head.
something that you fly in the sky.
Airplane, paper airplane.
A kite, right? It kind of looks like a kite. No?
Nah,
Do you guys not remember kites? They have like that little squiggly tail thing.
Looks like a duck.
they got drones now.
Okay, are we cool with lines of symmetry?
Yeah.
Let's try. Take a look back at that hexagon, right? A hexagon is how many sides? 6. So if it's a regular hexagon, how many lines of symmetry should we try to get? 6. So a regular hexagon is a hexagon that has all sides that are the same length. Okay? So like this is also a hexagon. 1, 2, 3, 4, 5, and 6. But are all sides the same length? So does this have any lines of symmetry? No. Do you see how, but they're both hexagons? A regular hexagon has all sides that are the same length. More. So try to determine the number of lines of symmetry for those 3 figures. Go. Don't say it out loud, Hayden. I want you to talk in your groups for 30 seconds. Figure it out. Go.
Oh wait,
Okay.
you won't believe.
So what were the 2 in number 12?
Straight and horizontal.
Straight down and horizontal. Yes, we all got those? Was a diagonal line of reflection or a line of symmetry? Was one of the diagonals? Is this a line of symmetry?
No.
No, because it's what figure?
The rectangle.
It's a rectangle, okay? If it was a square, would a diagonal be a line of symmetry? Yes, okay? Now, for number 13, I hope most of you got this one, right? Let me help you guys figure this out. We started at a corner and we went to the middle of a segment, right? Started a different corner and go to the middle of a segment. Line of symmetry? Yeah. Started a corner and go to the middle of a segment. Line of symmetry? Yeah. Started a corner, go to the middle of a segment. Line of symmetry? Yeah. 1, 2, 3, 4. Oh, did I say 5? Whoopsies. Oh, I missed one. I missed one. Yeah, there's one over here. There's 5. You see it now? Cody. Practice. You gotta practice it, okay? 14. What is the only line of symmetry? Zach?
Vertical one.
Vertical one, okay? Questions?
No.
Are we okay? Sophia?
I don't get the pentagon.
The pentagon?
Yeah. Wait, is that a pentagon?
It is a pentagon.
Okay.
Why is it a pentagon?
Because it has 5 sides.
5 sides, okay? So, Sophia, 5-sided figures, as long as each side is the same, try to go for 5 lines of symmetry, right? So, okay, I want you guys to try to draw a pentagon with absolutely no lines of symmetry. Go.
I got
With no lines of symmetry.
I don't know how to draw a regular pentagon.
What was that, Hayden?
You looked through what you just did, right?
That was a hexagon.
Yeah, but you did 5 times.
Pentagon.
Pentagon, bro.
I think I drew it wrong.
Boom. Boom.
Yeah.
What, like this or something?
Yeah, perfect.
I drew.
Okay. Actually, mine kind of looks like it has a line of symmetry. There we go.
Can't you split that in half? Wait, no.
This one?
No.
My other one that I drew?
No.
Oh.
Mine looks like a
So, how many sides does a pentagon have? 5. So check yours, make sure it has 5 sides. Here's another example, okay? There should be no lines of symmetry on your figure, okay? It should be a weird looking thing. Super weird. Questions?
Yeah, but see,
Okay, last thing. Oh, you have a question?
I think I got it.
is the inside?
Guys, this is an accident. This is not a pentagon. This is a hexagon. Thank you, Hayden. Good question.
What is that?
A hexagon.
That?
Yeah.
Are you serious?
Yeah.
Why does it look like that?
All you care about is how many sides it has, okay? All right, last thing, guys. We're going to talk about a glide reflection. It's a composition of a translation and a reflection, okay? Composition of a translation and a reflection, okay? So we're going to be moving our figure and then we're going to reflect it. So check it out. We're going to start with the points A at 3-2, B at 6-3, and C at 7-1. 3-2, 6-3, and 7-1. A, B, and C. We are first translating it by these rules. We're going to subtract 6 from the y values and keep the x values the same. Graphically, what's that going to look like, guys? On my graph, what's it going to look like? Not up.
Down.
Down how many units?
6.
Down 6. Are we moving it left or right at all?
No.
No. So if you move your graph down 6 units, 1, 2, 3, 4, 5, 6. Here's my new C. 1, 2, 3, 4, 5, 6. Here's my new B, B prime, C prime, and A prime. 1, 2, 3, 4, 5, 6. A prime. Then we're reflecting it over the y-axis, okay? Which one's my y-axis?
What are you talking about?
The vertical one, right?
Oh, yeah.
Oh, we do the opposite.
So all of my x values are going to change from positive to negative So it reflects over that axis. So A here was 3, and at A prime, my x value was 3. It's going to become negative 3. My B prime x value was 6. It's going to become negative 6. I'm moving it to the other side. And my C prime value is 7. My C double prime value is going to be negative 7. C double prime, B double prime, and A double prime.
Do you have to put the double prime?
Yes, because it's your second transformation. Why? But remember, it's still going to be a triangle, okay? It's just going to be reflected over that line.
Do we
John,
turn it in?
yes, you turn these in.